Let's get up the, no, don't want that. Want that. Okay. First thing we're going to do is what's called polar coordinates. This is another way to graph a point, like x comma y. You do that on a rectangular Cartesian plane. Now we're going to do it in terms of r comma theta, if you want to write this down. So when you have a polar coordinate, now these things are used, surveyors use this all the time when they're out. You ever seen those guys with the tripod and the little telescopes when they're looking and surveying? They use polar coordinates to figure distances. So when you look at this, and you're going to have to label this, these are either degrees or in terms of pi. What do they have number 1 as? Degrees. Okay. Somebody give me the ordered pair for that one.
2.5.
I'm sorry. 2.5 for r, and then 0 degrees. Okay. Now, I don't usually approach this like a normal ordered pair, and I think it's easier for you if you do it this way. Find the degree measure first. So you just go to the line. For example, we know this is 0 degrees, don't we? So that's the line or the ray that your point is going to be on. And we go out to 2.5 counting from the center. So we go out 1, 2, and a half. So you'll go halfway between. I didn't quite get that halfway there. Let me make that a little bit. See if I can estimate a little better. Calibration is off. So that is 2.5 comma 0 degrees. R stands for what normally in any situation? Yeah, you should think of radius immediately. And that's what it is. It's a radius out to 2.5. And like if you wanted to draw the radius of everything on that circle, you'd draw it all the way around. But all we want is a point. All right, let's do one that's negative. Does number 2 have a negative in it?
3.
Why don't you try number 2? Try and see if you can graph number 2. We got 3 comma negative 135. Now the line may not be on there, so you may have to estimate that and draw the line for it. Now remember, what do you do first? The degree measure first, right? Always do the degree measure first. You might want to grab one of those. You can just throw that away. Now, how would you estimate on your graph? Because these are already labeled, but they're not labeled in increments of 45 degrees. But what do we know about 45 degrees? Isn't it halfway?
Yeah.
This is a 90. So we know if we go 90, we need to go halfway, don't we? Which in my graph, there's a line there. On yours, there isn't, is there? So you need to draw the line. Unless you're good at estimating. But what I really like you to do is draw the line and label it whatever the degree measure is. Now that I'm on this axis or this ray, I go out to 3. Okay, so I go out 1, 2, 3, and put a point. How are we doing? Is this making sense?
Yeah.
Good. Give yourself a bonus point if you got that right. Now, I don't know if you'll know how to do this without an example, so I think I should probably show you number 3. Number 3 has a negative radius, doesn't it? What do we have for that one? -1, -30. Now this is where doing the degree first is really important. You all know where to go for -30, right? You know how to do a negative angle. Now is that labeled on your graph? Are they in increments of 30? Okay. Where does -30 put us? At 330, doesn't it? So that would be right here. Now, once we do this, let's see, is that right? 30, 60, 90, yeah. So I can make this -30, or you can, if your graph already has, the 330, it's okay, but I would like you to go ahead and put the -3 or -30 there also, just so I know that you know what you're doing here. Now, normally if that was a positive one, which direction would we go? We've been doing it in the last two problems. Don't we get on this and stay in this quadrant and go this way, don't we? Well, if it's negative, you stay on this line, and instead of going -1 or 1 this way, go in the opposite direction. So from here, we're going to go out. Now you have to stay on this same degree line. It's a straight line through here. Does everybody understand what I'm talking about? Straight line. So I'm going to go to here. So all the negative is you go in the opposite direction. Does that make sense? See if you can do number 4. On your graphs that I'm going to give you, actually you already have them. Your packet there has your homework and all the graphs you need when you do it, front and back on your graph paper. Nothing is labeled, so you're going to have to label it as you graph, like I've been doing up here. You don't have to label the whole thing, just label the ray that you're graphing it on. Now again, on this one, they don't give you pi/4, do they? So you have to go halfway. We know this is 0, and we know this is pi/2, so halfway is going to be pi/4. You'll have to draw your line. It's not on yours, is it? Okay. So do the best you can to get halfway between 0 and pi/2. Now this time, which direction do I go? What quadrant am I going to end up in? 3, right? So instead of going 2 this way, I stay on this line and go 2 in the opposite direction. And that's the coordinate for -2 comma pi/4. Do you think you need any more examples? How many feel like you're okay with this? Give yourself a bonus point if you got that right. All right. Now let's just go down to 7 and 8 and 9. These are not hard, but I want to see if you can figure this out without me telling you. Look at number 7. Now, what did we say R always represents? Now, don't say this answer out loud if you figured it out already. But we want to graph all the possible points on this polar graph where R would be equal to 3. We want every situation where R is going to equal 3. That's right, Tyler. Did you do it? Did you draw it? How many know what I'm talking about? Because I said earlier, R stands for what? And what do you have when you have a radius? So guess what you should draw? Wouldn't that be the circle? You go out 1, 2, 3. So wouldn't this be where r equals 3 in every case? Does that make sense? Give yourself a bonus point if you figured that out before I did and did that. Now do number 8. This time we want a graph of where theta is going to equal 60 degrees in every case. Okay, what should I draw this time? Say what? Yes. First you find 60, which would be 30, 60 would be right here, right? Wouldn't every point that would be on the 60-degree angle line have to be, and you'd have to draw the whole line. Does anybody know why? Yeah. Don't you also have negative r's, comma 60 that would put you down here? Remember how we graphed the negative and it put us in the opposite direction? Now, notice what else did I put on this? Yeah, this goes on forever. I'd take a point off. Remember, I get on you all the time about details on your quizzes. Some of you don't pay attention to detail. You don't think they're important? They are important. So I'd take a point off. You don't put arrows on that. How many had this before I did? Give yourself a bonus point. This is easy, isn't it? So I wasn't lying, was I? All right, last thing I need to, well, not the last thing. Let's go turn your paper over first. We're going to come back to the other examples since we've been doing this. Turn your paper over. Let's see if you got this concept well enough to do this little exercise here. I've graphed a point, and you'll see at the top, I want you to give me 4 polar coordinates for that point. Give me 4 ways of writing a polar coordinate for that point. Now let me give you one way that doesn't count as a different way. You can't, you're obviously going to use 330 there. You can't use the pi for that as another example. Are you with me? Okay, like you can't use 11 pi over 6 and 330 with the same r. That's not the different I'm talking about. I'm talking about different ways of getting to that point. 4 different ways. What's the obvious first one that we all would probably write? 5 comma 330. That's the first one you probably would write because that's the obvious one, isn't it? Now your r's can be the same if your thetas are different, and that's a different way of writing it. So what's another way I could write it with a 5? 5 negative 30, right? Very good. Does everybody see that? Okay. Now the other way to do it is with a negative 5, isn't it? Okay. So hold up your hand, please, and give me one with a negative 5. Okay. Because that would work, because if we go from 0 all the way to 150, if my 5 is negative, I've got to start here and go negative, and it would put me there, wouldn't it? All right, what's the other one that we could write with negative 5? Tom? Say it again. Yes. Negative 210. How many had that? Okay. Now there are, do you remember our circular angles? You could double that, couldn't you? Add 360, or not double it, excuse me, add 360. Because wouldn't that 360 bring you right back to the same point again? So if we add 360 to that, what would we have? So you could have 5 comma 690. Does that make sense? Same way here. You could add 360 to that and get another one. But I prefer the ones that aren't multiples of 360 first. See if you can write those first. So you'll have some problems like that. Give yourself a bonus point for each one of those you wrote on your own. I only have one more example and we'll be done here. Let's go back to your front page there at the bottom. And this is just a formula. This is when you're going to need your scientific calculator for finding the distance between two polar points. And I'm going to give, I'm going to give you 2 bonus points if you can tell me what this looks like when I write the formula up here. I doubt if you'll remember, but I've been surprised a few times in the last couple of years. Some people have remembered this. Actually, let's go to a plain screen. All right, we got, what are the 2 points on this one? All right, we've got 6 comma 90 and, thank you, 2 130. All right, here's your formula. It's a square root r sub 1 squared. R stands for radius, yes. Well, I'm not there yet. No? He just wanted to jump on that, wasn't he? Plus r sub 2 squared. You know what I'm talking about now, the 2 radii. 6 and 2, right? Then it's minus 2 times r sub 1, r sub 2 times the cosine, don't say it out loud if you know, of theta sub 2 minus theta sub 1. Now you do know the first coordinates are the r sub 1, theta sub 1, right? This is your r sub 1, theta sub 1. This is your r sub 2, theta sub 2. Now all this is plug and chug after this and make sure you get your order of operations right. Now does anybody recognize that? All right, I'll give you a hint. It's on, it's something we did last semester. That's why I didn't know if you'd remember. It's one of our laws. It's pretty obvious, isn't it? Thank you. Law of cosine. And you probably don't remember that, do you? It's also very similar to, well, let's not get into that right now. All right, let's see if you can plug and chug here without me showing you. Plug it in, work it out. Now, if you know how to use your calculator correctly, I'll show you how I do it in a second. I'm going to see if you can do it on your own. There's a way to get down to a certain part of it to that form, and you can just run it straight through. But go ahead and see if you can figure this out. And once we're done with this, this is everything we're doing, so, in this section. Let's round this to the nearest hundredth on everything that you do. Homework also. I don't think the directions specify, but let's do everything to the nearest hundredth. Anytime you want to be safe, giving me more decimal places is better. Less is worse. Because more decimals are more accurate. So if you give me to the thousandth, I'd be happy too. But if you want to round it, no more rounding lower than the hundredths. Or higher than the hundredths, I should say. Okay, let's plug it in. And we'll see if you got it right. How many already have an answer? Well, let's see what we got, and then I'll work it out. What'd you get?
4.65.
How many got 4.65? What'd you get? All right, the answer is 4.65. I just see if anybody else had a separate answer or a different answer. Now, the order of operations is probably why you made a mistake here. We got, 6 squared plus 2 squared minus 2 times 6 times 2. And what's theta 2 minus theta 1? 40. Now, I wouldn't run it through yet just to be safe, but 6 squared is 36 plus 4 would be 40. Isn't this a 24? Yeah. Here's where I can stop and run it straight through without an error in my calculator. That's where I would go to. Now here's where people make a mistake. You cannot take 40 minus 24 times cosine of 40. No. Can anybody tell me the reason you can't? By multiplication, right? What's the order of operations? What do you always do first? Please excuse my dear Aunt Sally. All right. We don't have parentheses or exponents. What comes next? Multiplication. You can't subtract here. How's this 24 connected to this? Multiplication. So you have to multiply these first. So what I do is I work in reverse here. I take cosine of 40 times negative 24 plus 40. Now, if you want to put it in the other way with parentheses, you can. But that's how I do it, because I can run it straight through, no parentheses. It's called order of operations. What am I doing? Multiplying and then adding, right? Then I just hit my square root button. That's a positive 40. See, this is like a negative 24, and this is a positive 40, isn't it? So it's a negative cosine of 40 times negative 24 plus 40, since it's a positive 40. Then you hit your square root button. You should get 4.65. How many got that again on your own? Does anybody else need another example? Do we need to do the other one? No? Are we okay? Okay. Your assignment's on the board. You got that also in your packet. You'll have today and tomorrow to complete this. Quiz on Wednesday. Oh my goodness. This is an easy one. You should get an easy grade on this quiz. Maybe I should cover 2 sections first.